Good afternoon, class, and welcome back to Chapter 7, Section 5, where today we'll be talking about using proportional relationships. So for you, I just have a couple of definitions. I have one theorem, some examples, and then that'll be it for this evening. So let's get started with some definitions. So remember, at any time you can pause, write down what you need to write down, and then push play to rejoin me. Okay, first definition we have today is indirect measure. An indirect measure is any method that uses formulas, similar figures, or proportions to measure an object. And you've probably done this in the past in elementary school where you're asked to measure something, an object without a tape measure or a ruler. So maybe you measure it with paper clips or a dollar bill or even your hand. So any form of using anytime you use something that's not meant to measure, like a tape measure, then you're using an indirect measurement. And we do this even when we solve proportions. All right. The second definition we're going to do is scale drawing. And we've seen scale drawing in the past also. So let's get a formal definition and then push play and we can talk about it. So scale drawing. A drawing that uses a scale to represent an object as smaller or larger than the original object. So if you think back to biology class and you look in your textbook and you're looking at a drawing of an atom or a cell, that's a scale drawing. We're representing something that's too small to see with the eye, so we draw it much larger so we can see it. Same time, if we go to geography class and we're looking at a map of Texas is too large for us to see all at once with our eyes, so we scale it down so we can see it in something smaller. Well, when you're looking at scale drawings, you'll also notice that they have a scale near the compass rose in the legend. That scale is the ratio of any length in a drawing to the corresponding actual length. And you've seen scales that we've done in class also when we talk about 1 foot being represented by 1/4 of an inch, like yesterday's warm-up. And here I have also printed you a scale. This one came off a map example that I found where it says that 1 foot represents 24,000 feet in this map. And then they show different scales, measurements for a mile, for feet, and even for kilometers. So we've seen these in the past. Now we're just going to do some application problems with them. All right. And then our theorem, I'm going to move to the left. We have a theorem that's called the proportional perimeters and area theorem. So if you need to push pause, go ahead and write all this down. If you don't have a Post-it note, that's fine. You can write it directly onto your comp book and then push play when you're ready to go. Okay, and welcome back. Our proportional perimeters and areas theorem states that if a similarity ratio is A to B, then the perimeter ratio is A to B, and the area ratio is A to B squared, or we can say A squared over B squared. So this is going to work when maybe I only have one side length and one perimeter, and I'm looking for the other perimeter. I don't want to have to go and find all the missing side lengths to find the perimeter. I can just use this kind of theorem and shortcut some stuff. So let's flip it up for an example. And I'll give you a moment to draw it. Push pause and go ahead and draw your picture. Okay, and you've had it drawn, and it says that pentagon ABCDE is similar to pentagon JFGHI. So this one is similar to this one, meaning all their side lengths are proportional, including their perimeters and their area. So if I'm giving information one side length of the top pentagon, the top pentagon's perimeter and area, then can we find the ratio and use it to solve for area and perimeter? So let's find the ratio first. And here's our ratio, 90 over 60. And when I reduce, I get 3/2. So let's see if we can find the perimeter first. So here we go. 3 halves, so the one from A, B, C, D, E over F, G, H, I, J. And if we cross multiply, 2 times 380 times 381. And I get 3P equals 762. Divide by 3. And I get a perimeter of 254 units. Or in this case, it's meters. 254 meters. Okay, simple enough. Now let's go through and see if we can find the area. Now remember, when we're doing area, it has to be the scale factor squared. So I'm going to take 3 halves, which is our ratio, square it, and it turns into 9/4. So 9/4, oh, can't see it, let me move up some, equals the area from the original one over my unknown area. That's what we're looking for. So now I can cross multiply and divide just like I saw proportions in the past. So 4 times 1,944 equals 9A. So if I divide by 9, now I have an area of 864 meters squared. Don't forget to use your units, and anytime we talk about area, we are units squared. Okay, so that's an example of how the theorem, the proportional perimeters and area theorem works, and we'll have more to do in class. Now I want to go and look at using a indirect measurement to find a missing side length. This is the one you're probably going to use most frequently. All right, so say we have a tree in our yard. Here's our tree. And I want to know how tall my tree is. I don't really know. I don't have a tape measure that's going to go for the whole height. And my mom doesn't like me climbing the tree. She thinks it's unsafe. But any time in the afternoon, I walk outside. I found that the tree's shadow was 5 feet, or 15 feet and 15.5 feet. And I'm going to use my height and my shadow to see if I can find the measurement of the tree. So at the same time that that shadow of the tree is 15.5, my shadow is 7 feet and 9 inches. And I know that I'm 5 feet and 2 inches tall. Now you can see there's a relationship between the tree's height and shadow and my height and shadow, and we're going to set up a proportion to solve. Before we can do that, we notice that this height and shadow is in feet and inches, and this one is only in feet. So I want to convert them both to all feet, so we don't have two types of dimensions going on, or two types of units. So I'm going to convert my height, 5 feet 2 inches, to just feet. I'm going to convert my shadow to just feet. We'll talk about in class how to get that conversion if you don't remember. Now I'm ready for my proportion. So I have my height over my shadow is proportional to the tree's height over the tree's shadow. And again, just like we've been doing in class, just like I did on the previous problem, solve your proportion with multiplication, then divide, and I have a tree's height of 10 feet and 30, which is 10 feet and 4 inches. And again, we will talk about those conversions in class. So that's all I have for you today. Hope you enjoyed taking notes, and I look forward to seeing you in class. Have a great evening.